And try to remember, put your shoes on the foot of someone who doesn't get skills easily in some academic area. I know in Northern California that's extremely rare because of the gene pool, but just try to remember when that may have been. Now, I told another group this, and this is part of my therapy, so I'm going to let you all know what this is like. When I was in the 7th grade, I went to Algebra 1, and my math before that had not been good. I didn't come to math easily, and I did very well in Algebra 1. I actually made A's, which blew away my grandparents, who I was brought up by. And throughout that year, they just started to expect to see A's coming home on my Algebra 1 work and on my report cards. When I got to Algebra 2, it was a little distressing to them because by Christmas I already had, over every marking period, the big F, and all my papers were F. And so they were quite disturbed. They wondered if I had a slow-growing malignancy in my squash. But I told them the truth. They said, "What's going on? You're not studying? You look like you're studying." I said, "Well, I am studying." I said, "Well, what happened?" I said, "Well, Jimmy Singletary moved to Boston." Jimmy didn't know how to cover his paper. And I was, and I feel terribly guilty about that, and it's part of my 12-step program for cheating. But what I had to do then was go to tutoring, where I had a very good tutor that brought me back through some concepts in Algebra 1, and I could do binomial expansion, and I could see factoring. Then I'd go back to my regular classroom, and this guy was clicking on very fast. Everybody around me was going like this, and I lost it. It was too quick. It didn't relate to what my examples were with the other person, and it was very hard to hold on to. That's what a lot of these readers deal with when they are taught nicely in more intensive settings, but then have to generalize to other settings. I don't know about you all. You don't have to work with special ed kids to know that anybody having a tough time learning something has a big difficulty learning it and carrying it to another skill or another setting. Generalization is a bear. And that's why we know, as you'll see this afternoon, if you teach phonologic awareness and hope that that's going to generalize to reading and comprehension, it's not. They'll be good phonologically aware kids in the main, but they're not going to learn how to read because of that. You have to take that phonologic awareness stuff and integrate it nicely with the letter sounds. Phonology is sounds. You got to integrate that with letters. When that happens, that's called phonics, or phonics is also an approach, but it's also the idea of letter-sound correspondences. They're two different things. And actually, we do studies to figure out if you're teaching phonological awareness, do you use bingo chips to represent the sounds, or do you put letters on top of those bingo chips to do phonics and phonological awareness at the same time? And we're starting to get some nice converging evidence on that, which says, why not use the letters? But the point is, you've got to have this underlying sound structure, but that's necessary but not sufficient. It has to be integrated with the letter sounds, and that has to be now moved forward with tough readers in a very decodable way. And here's where I need to duck, I think. We're talking, unfortunately, about the studies that are telling us that you have to keep consistent the word targets that you use to teach phonology and word attack decoding skills. You try to use as many of those targets in running text and make that as interesting as you can. That's called decodable text. If you are using predictable text, words predicted on the basis of colors, semantic or syntactic structure, for a large number of your readers, ladies and gentlemen, it will not be powerful enough. It will just not work for you. And I don't know how much I need to say about that. I probably am not going to convince anyone that actually believes that these kinds of cueing systems can circumvent some things that these kids show us every day. But here's the problem. What we want children to do is read on the left the text of whatever it is, a social studies book or a novel or poetry, and we want them to go all the way to the right to meaning. But there has to be, in an English orthography, in an alphabetic language, some basic work done if you're going to get there. Some people do it quickly. But a lot of children in our classrooms are kind of bottlenecked at that black thing there, the decoding, the sounding out stage, which leads to very labored word identification. Now, if in fact semantic and syntactic cues could circumvent those kinds of bottlenecks there, why don't they? The children you saw at the initial part of this talk had very nice general intelligence, had very strong vocabularies, at least initially, but by the way, vocabulary and semantic development goes down with reading performance if it's bad. They've got good reasoning and conceptual skills, and they cannot use those particular traits their syntax, their vocabulary, to swing around and predict from a variety of cues what they're bottlenecking on. That's the unexpected paradox of reading an alphabetic orthography. It's there. So if you have a philosophy that wants to use all that, keep in mind that there's, yes, as readers learn how to do this code stuff, they actually begin to depend more on code rather than context. It's the young readers that'll use more of your context initially, and they gradually move over to word cues and morphological cues and orthographic cues, which Louisa will talk about. That's what developmentally it looks like. Why am I so dogmatic or seemingly dogmatic about this? Because we study enormously large groups of good, medium, and lousy readers, and we can't refute it. It won't falsify. So at the same time, we look at a lot of children who come to us in classrooms who don't have such high general IQs and such high vocabularies. These are kids who come from families where they've never even seen a book. There's no books in the home. There's no bedtime reading. There's no Dr. Seuss. These kids have a parent who works 3 jobs. There's not dinner table conversation. When they get to kindergarten and first grade, they don't even know how to hold the book. Some of them hold it upside down. They come to us in the studies as more frequently, obviously, than do the very bright kids with reading problems. And we see with these children that they still show us this same slow, labored decoding. Yes, and their syntax is off and their grammar is off, and they've got to develop a lot of vocabulary. But for those children as well, it is this bottlenecking part that gives them the worst pain. And if we go after them and help them very intensively in kindergarten and first grade, we'll show you film of how we do this, then they come along, quite honestly, much better than those kids who are very bright with these severe difficulties. Let me give you an example. In our Houston studies, we have children from all walks of life. The Title I children who are on free lunch, actually, as you'll see this afternoon, have moved from about the 10th percentile in both reading words and comprehension to the 49th percentile, where about 5% of those kids aren't moving at all, and those are the brighter kids, the more dyslexic kids, if you will. So we're in a situation where I think we're getting a fairly good handle on the kinds of conditions that need to be in place for human beings to learn how to read an English language and love it. Some of those conditions are, you have to understand something about a sound structure. That has to be integrated nicely with phonics, as terrible as that sounds, and that has to be pushed forward into very vibrant text to create interest and to practice to develop speed and fluency. I don't know how to get around those kinds of bottlenecks which aren't so exciting. But how exciting we make instruction on the code stuff isn't an instructional issue, it's a teacher issue. I mean, people ask me all the time, well, my goodness, I've got a 16-year-old who reads it at second grade level. What am I supposed to do? Do I have to do all this coding stuff, all this phonology stuff? The answer is pay now or pay later. Yes, the question is, how do you show it to them so your materials don't end up where the sun don't shine? That is very difficult to work with kids that have been through 8 to 9 years of failure when they do have to learn these conditions if they're going to be independent readers. I'm not going to take too long of your time. The person that knows the most about what we're talking about is coming up after me. That's Louisa, so I'm going to get out of your hair here in a second. I did want to mention to you, because a lot of people asked on the break, that we at the NIH, we not only do the long-term studies where we study reading and its development, but a lot of the youngsters are also studied in terms of how their brain develops and so forth and so on, because we're interested in that. In particular, we're interested in when we see kids who don't read well, do we have biological correlates with that kind of thing? And the way we go about doing it is non-invasive. I'll show you some pictures, and I'll be going through this very quickly. It's just for your interest and so forth. But what we're trying to do is understand what brain systems handle language and reading kinds of things to help people do it well. And if you look at this particular picture, this is an MRI. Some of you may have had one of these things before. And clinically, when they're used, they're kind of loud. They bang when you're inside there, and they're also fairly slow. You got to hang out in the tunnel for a while. The procedures we use are fast and silent. Kids, after they're trained on mock-ups, do quite well inside. It's the adults who freak out and get claustrophobic, actually. And these are a bit different in terms of when you have magnetic resonance images taken of your brain, you're typically looking at anatomy. We are interested in what that anatomy is doing. That is how the brain functions when the kid tries to read, spell, listen, speak, and so on. So what you see up here is kind of the way it's done. That's me inside the gantry or the tunnel. You can tell that's me by some very ugly, skinny feet that you wouldn't want to see up close and personal. That's my medial aspect of my right hemisphere. Our tech has taken off my left hemisphere, just like somebody took off my son's frontal lobe. And so I've got, my corpus callosum isn't bad if you ask me. Cerebellum's looking okay. It's not so embarrassing that my feet are so ugly. What is embarrassing is how small my frontal lobe is. But anyway, what we really want to do with these kinds of things in basic science terms is to understand how the brain handles complex behaviors. And one way to do that is to ask the brain to behave and watch which systems in brain seem to make that behavior available. You can't see very well the top slides. Just to give you an orientation, you're looking at left hemisphere, so if I'm standing here and you take off the left side of my skull, you'd be looking at that particular view there. You see some blue on that, right? All right, the blue reflects resting cells. Those cells aren't working hard at all to do much. Up at the top there, hold on, I hadn't even got to the good stuff. Nobody's going to take me seriously. This is serious. Up at the top, you can't see it. It's cut off a little bit, but you see the gold up there? Top slide. Well, what this person is being asked to do is just count or think about counting from 1 to 10. And what the slide is showing you is that a system in the anterior, there you go, thank you. The anterior region is pulling more blood and glucose and oxygen into those cells. And the idea is that those cells are working hard to plan what that individual's brain needs to do when it in fact does count from 1 to 10. And if we were to measure planning kinds of behaviors in that regard, generally this system called the supplementary motor area gives us that kind of physiological signature. So it's kind of common sense. What we're doing is tracking the amount of blood that goes to certain brain areas because blood is providing the nutrition for the cells, and that nutrition is glucose and oxygen. So these are correlative studies. They can be seductive because these things are colorful and you actually think you know what's going on. We don't know a lot what's going on, as a matter of fact, but we can see relationships between how the brain operates and how certain behaviors are performed. Let me see here. Who is that going to be in the middle? Since I'm on film, we've done a number of studies of famous individuals around the country, and the middle slide is Rush Limbaugh thinking as hard as he can. But I'll move off. You're now looking at another left hemisphere. The resting cells are in red. The gold that you see there reflects, we've asked the computer to color those systems in brain that are working hard to do a rhyming task. So the individual in the gantry, a 10-year-old youngster who's quite a good reader, is listening to nonsense words that rhyme and pressing a bulb if in fact they do. And what we're picking up there is a fairly reliable signature that most right-handed brains will show you, in the sense that this rhyming stuff, the phonology kind of thing, is you can see fairly modular, circumscribed. What I want you to pay attention to is you don't see any gold activation or any activation as represented in gold in the frontal areas, do you? No, and that's why you can teach a lot of kids, for example, youngsters with mental retardation who can do phonological awareness, rhyming, and phonics or word calling quite well, but don't have any idea, in fact, what they're reading. It shows you the dissociation between different systems that handle different parts of reading. That's also why the 4 kids that I showed you when we started out this morning, being very bright, can have difficulties because when they're measured, you get a diminution or a degrading in the signature that handles that particular kind of function. So they can listen and speak and reason and have fairly strong vocabularies, but these teeny sounds seem to be somewhat elusive to them unless we represent those in very concrete ways. Now, a lot of the studies that we are doing, particularly in Seattle, Washington, and at Yale and Syracuse, are looking at youngsters at 5. Actually, we're starting at 7 this next year, where kids who are not good readers are imaged. Then they are assigned to different interventions. And if we get a good reading change, we're wondering whether or not we get a concomitant physiological change or whether there's a compensatory system that picks that up. So that's the level of detail that goes into these kinds of studies. I will tell you that if you use kind of these frameworks to guide your teaching, the linkage between what you're seeing now and applied stuff in the classroom to me is pretty long or far. There's a distance between it. But I will also tell you, and I'll probably get in trouble, but when you're talking about learning styles and multiple intelligences and those kinds of frameworks, while they're wonderful to help us understand that kids do differ in terms of how they learn, they're not very robust in guiding instruction. Because when you're learning to read, whether or not you're a visual learner or an artistic learner or whatever style or intelligence you're using, you still have to be able to understand that words have sounds, that those sounds map on top of letters in a phonics situation, and that has to be moved along in very interesting text so that a kid, as we've talked about all day, knows that reading is gaining or constructing meaning and really loving to do that. So I just passed through this quickly. Obviously, we could spend several days on this particular topic. This is the more basic aspect of what we do, as well as the genetics that we study. We have the largest twin studies in the world, where you can take a look at what is inherited, in fact, in kids who have reading difficulties by looking at twins, because monozygotic twins or identicals with one reading difficulty or one twin having a difficulty will certainly have the other twin having the same. Now, what generally is heritable in that, with some exceptions, is the linguistic part. This phonological part seems to be what is inherited. Reading isn't inherited. It's evolutionarily too young to have hardwiring deployed to that. It's the linguistic foundation that seems to, the strength or lack of strength in that particular skill seems to be penetrable or transmitted across generations. But it's not sex-linked. It's an autosomal probably, and it's polygenetic. That means multiple genes are going to influence our ability to read. It's not a single gene phenomena like Down syndrome or Turner syndrome or neurofibromatosis or Fragile X, those kinds of things. But Sally Shaywitz and Ben Shaywitz's shop at Yale do some of the best neuroimaging in the NICHD network, and they publish a lot of this in journals like Nature and Science and so forth. But frankly, their best publication is in the Weekly Reader. And this is true. We publish this in the Weekly Reader, and it's the first time I've ever understood it. And they let me draw the brain for the Weekly Reader, and now look how big my frontal lobe is. Okay, I'm going to take you through rather quickly the intervention studies that are moving along. The question, as I mentioned this morning, is a very practical one. For which children do certain teaching approaches, methods, philosophies, or combinations thereof have a good probability of success with children? The studies are done in the same way as we do basically everything I've talked about. They're longitudinal in nature. They are large N studies. Very large groups of kids are studied, relatively speaking. The replication trials proceed at each site and so forth and so on. And we've been at this for about almost 4 years, going on a 5th year. So the data are new. But just like in any information the NIH transmits, once we start to see strong trends that are replicable in terms of how you help human beings, we start to publish that immediately. So you'll be, now just as we would if we were treating cancer or we were treating tuberculosis, which again is on the rise, as you probably know, as the data are through peer review and replicated, they come out as quickly as possible, and this is one way we do it, by talking to groups. The first thing I'm going to take you through is one of Barbara Foreman's studies, who directs the Houston projects, where she's working with approximately 72 teachers in as many or more schools. Again, these are population studies and longitudinal. The intervention studies the NICHD is interested in are based on 3 levels. One type of study is a prevention study. Obviously, we would like to get to children before they ever experience any difficulty. And one way to do that is to start with 5-year-olds in kindergarten and see what works. Not only what helps kids who are going to be poor readers, but also helps everybody. So the study I'll describe for you here is one taking place working with 5-year-old children and then moving along for 5 years. The intervention is actually done in kindergarten, and then we follow those kids 4 more years, and as the kids leave kindergarten, they are assigned to different teaching approaches. So we can see if gains are made in some skills in kindergarten, whether they maintain over time, and whether the maintenance of the skills over time is influenced by how they're taught in the 1st, 2nd, 3rd, 4th grades. Make sense? The IQ age or the IQ range is free to vary, as in any population study. The ethnicities are free to vary, so you're getting a sample of kids who look like the general population. In this particular study, 7 teachers were trained, 30 hours in training, their average experience 4.8 years. These are little ones, 5 to 5.5-year-old kids. They don't hang with you much beyond 20 minutes per day, 8 months per year, and the student-teacher ratio in this particular study I'm reporting is 1 to 6, but this has now been generalized to 1 to 20, 1 to 25. In fact, you'll see a lot of film where the groups are much bigger. What is being done with these kids in Scandinavia and in Denmark in particular, Lundborg and his folks have for years been putting together some activities that you can do in about 30 minutes that work with kids' idea of these language structures, particularly the smaller language structures that undergird reading performance in alphabetic languages. So they do a lot of listening games. They listen to things where the kids pick out specific sounds from a background of sounds. They do a lot of rhyming. They listen to sentences and divide the sentences into words, telling you how many words are in a sentence, in a sense segmenting the larger chunk of language into smaller chunks. They segment by syllable. They work on initial sounds, final sounds, and then phoneme segmentation. Now we're going to show you some film of what that looks like. But just by way of background, if you work with children in this program, as in the Houston program, what you're going to see is about a 1.3 standard deviation superiority in kids who have this particular series of activities in kindergarten versus those who have what would be called a developmentally appropriate kindergarten, where these kinds of things aren't explicitly taught, where social skills and general kinds of reading things are done. Kids are read to a lot, but nothing specific. This is a lot of fun. And by the way, over the break when we were talking about a reading program needing to be complete with respect to making sure kids had phonological awareness and phonics, someone came up and said, my goodness, are we going back to the Fan-Dan kind of past practices? And clearly that's not the case. We'll be trying to show you today where all of these code issues have to be made extremely interesting. That's a teaching job. It's not so much a reading issue, it's a teaching issue. How do you get these skills to folks at different ages and make them very interesting and weave it all together so it eventually leads to meaning with the kid? So Michael, if you can help me with that slide, I'll try to see if this works. Now the first teacher you're going to see here, she cracks me up. Let's see if...
Pull from the box are the little students that I see with their legs crossed, with their bottoms on the rug, and raising their hands. Those are the only ones who can pull something from the box. Okay? This is the box we're pulling from. And when we pull from the box, we're going to clap to each syllable that we hear. We know syllables are part of the word. The syllables are each part of the word that we say, hands down. I'll do the first one, so you'll know how to do it. If I pull a finger from the box, I want to clap to each syllable, Serena. I want to clap to each syllable in the word what? Fingers. Fingers. So I'm going to say fingers. Good. I think you know how to do this. Okay? Only the ones, what did I say? Only the ones who raise their hands and keep their bottoms on the rug. Okay, we're going to be nice and give everyone a chance. Ready? I think I'll start from the front. Brendan, pull something from the box. Brendan will say what he pulls, and Brendan will clap. What is this?
Alligator.
Good, Brendan. Put it on the table. Let Brendan say his word. Whoever comes up gets to say their word and gets to clap. Brianna, let's go. What did you pull? A boy. Clap the boy. Good. Very good. Reginald, pull from the box. We're going one at a time. Pull from the box. What did you pull? A bear. Clap the bear. Bear. Reginald did a big clap to bear. Did you see Reginald's clap? He said, bear. One big clap. Come on, Candy. Everyone is going to get a chance. You just have to wait for your chance. Can you get something, Tammy? You have a, ooh, what is this? A what?
Cricket.
A cricket. Clap the cricket. Only Tammy. Do it again, Tammy. Good, Tammy. Put the cricket on there.
I don't know about you guys, but I would not lift my butt off that rug.
What card, boys and girls? 5. Listen. 5. Johnson, take the next card, please. Please. Say the card. Please. Listen. 5. Fish. Do these words begin with the same sound?
Yes.
Yes. What sound do you hear? Yes. Good for you. Pick a card. Crystal, come and choose a card, quickly.
Lion.
Lion. Good, Crystal, pull another card.
Locker.
Lock. What picture?
Lock.
Thank you, Crystal. You must go back now. Lion. Lock. Do these pictures begin with the same sound?
Yes.
What sound do you hear? Good listening, yes.
Michael, if slides, please. So you can see they'll go through final consonants, segmentation of syllables as you heard them clap, and then phonemes, the actual teeny sounds where they use Legos to put those together. Those kinds of concrete things, manipulables, serve as mnemonics to let kids, I don't know if you all have ever worked with tapping exercises where you get kids to tap out the number of sounds in a word or the number of syllables in a word. So, for example, you might say, how many sounds do you hear in the word cat? Tap it out. And the kid will tap it out, tap 3 times. If you use these mnemonic, manipulable kinds of things, the kids can not only see it, but they see the sequence as well. When the tapping just obviously gives them a temporal idea, now you get a spatial and temporal idea. So some of the things you'll see later on in the films will show you how these concepts are represented to make them concrete enough for kids that just do not get the abstractness of sound. In this kind of study, the prevention study, for several times per year, and for all of the 5 years of study, a variety of downstream variables, dependent variables, are assessed. Blending phonemes, phoneme elision, say big without the b sound, word attack skills, word recognition, passage comprehension, textual reading and comprehension, looking at words correct per minute, errors per minute, and then in terms of comprehension, main idea, inference, sequence, summarization, and so forth. Listening comprehension, vocabulary development, and grammar and syntax are looked at basically several times a year, and you'll see why in a little while. Now we're going to look at a program that is clearly the best of all worlds in a sense, because there's a 1-to-1 student-teacher ratio with Joe Torgeson's prevention program in Florida. There's a large, by the way, all of these, you're seeing the first study slides. These are all been replicated, so the numbers of children have gone up dramatically in these studies. But in this particular study, you have children from 21 schools with kindergarten. They're going to begin receiving intervention or prevention at 5.5 years of age. The IQ is free to vary, so you're looking at a lot of youngsters and so forth. There are 52 teachers in training in this particular cohort, 60 hours to train them. Then the kids get 20 minutes per day, 4 days per week, a 1-to-1 student-teacher ratio. Now, these kids are all below the 10th percentile on the predictors of reading and on measures of early reading. So they're all below the 10th percentile. They're going to be assigned to a number of different conditions. One is an embedded phonics condition, where sound-symbol relationships are learned in context. A second is a combined program. It's called PASP, P-A-S-P. It combines phonological awareness, synthetic phonics, and then integrates that into running text and comprehension exercises. The regular classroom support program, the RCS, is whole language with phonics taught in context. And the no treatment control is whole language with no explicit attention to sound symbol relationships. These are the descriptions of the programs, and I can come back over this, but let me just get to the, all right, again, if we could focus a bit. If you look up at the top, there are color codes for the different groups. Gold is the regular classroom support, whole language with some embedded, some contextualized phonics. The combined program that deals explicitly with phonological awareness using these manipulables and also teaching the kids where in the mouth the sounds are made, like Pat Lindemood's program does, if you're familiar with that. And remember, sometimes the mouth orientation is necessary because different sounds are made differently according to where the sound is in the position of the word, the position of the sound in the word. Embedded phonics, again, is a phonics approach that teaches sound-symbol relationships in patterns via context. The control is whole language without explicit work on any code. What you see in word identification all the way to the left, if you could see it way in the back, the white bar is going to show you the average readers in the classroom. This is at the end of the second grade. Now, from kindergarten at the end of the second grade, you see your combined program, phonological awareness, synthetic phonics, all blended into contextual reading, pretty much doing fairly well, and no difference between them and the average readers. You see that the regular classroom support, whole language, plus some contextualized phonics, and the embedded phonics are fairly equal, not quite up to average readers. And your whole language control for these children below the 10th percentile is not moving as well as we would like. Word attack skills, you can clearly see the advantage of a combined program that does accentuate early sound structure, blending that into phonics, moving that forward into connected text and comprehension versus the other more contextualized approaches for these students below the 10th percentile. And you'll keep hearing me say that because obviously these are clinical trials, just like we do clinical trials with pharmaceuticals, with surgical techniques. They're all designed that way. The controls are designed that way. There are placebo conditions up the wazoo and so forth and so on. And so what you have to be is very specific vis-a-vis which kids are in the study for these children. They're very well defined. They're all below the 10th percentile. Some of them have very high IQs. Some of them don't have very high IQs. By the way, IQ doesn't enter response to word identification or word attack kinds of things. Why? Because you saw in one of the slides, when we look at brain system work for those skills, it's modular. It doesn't pull a lot of frontal lobe. Passage comprehension, we get a significant group effect for the PASP kids, PAS for the combined program, significantly better than all others. But notice, if you can see it, that the red bar, the combined group, still isn't close to the average. And that's because the average IQ for these kids is 95. Even with the high and low IQs, when you average it, it's 95. Listening comprehension is about 95. And so they're constrained by their listening comprehension. You with me? Now, Bob was talking very well about the fact that group data are one thing, but in the studies that we do, we have procedures for pulling each individual child from any group and tracking that youngster across time so that we know not only how much that child has learned, but how fast it took them. And look what it looks like when you do that. In the top slide, we're looking at word attack. If you can see that top slide, you've got a black curve that kind of looks like a half crescent there that goes up. Those are the normal readers. The red slide there is a child from the PASP program and a child from the embedded phonics program. But as Bob was talking, look at how the kids go along not making many gains. They were both making kind of equivalent gains, but then one kid took off quite a bit above another. So these are individual children. Not only can we look at individual children pulled out from the samples, but we can predict into those lines, into the slopes of the line. So if you get a very nice boost in reading, we can see if in fact that's related to socioeconomic status, to amount of literacy in the home, to the type of classroom pupil-teacher ratio, to what's going on in the classroom, and so forth. So all of that can be now attended to. In other words, these are some of the first studies where we've learned how to look not only at the reading behavior, but the surrounding ecology, to try to understand what influences the actual teaching procedure. Nothing happens in isolation, obviously. So all of these procedures try to figure out as much as possible the influences in a child's life and to do it in an objective, empirical way. The bottom line shows you a couple of more kids in terms of their growth curves, and you're looking at word identification and seeing the difference between one kid out of that combined program and another kid out of the embedded phonics program, just as an example. All right, I'm going to take you through something that I'm going to have to talk you through. These are the Houston studies that have gotten some publicity and frankly haven't been described in the press very well at all, so I'm going to do it verbally with you. Barbara Foreman, again, is running prevention studies. You saw the first one I put up there was a prevention study. These are now second and third grade early intervention studies, and we're looking here at Title I children, or children eligible for Title I. They are economically below a certain level for free lunch, and they're reading at least below the 25th percentile. The average reading score starting here is about the 12th percentile on a combined measure of decoding, word recognition, and comprehension. They're going to be assigned to 3 major classroom conditions where the student-teacher ratio is about 1 teacher to 20 kids, to 24 kids. The classroom conditions consist of whole language classrooms where the whole language teachers have a general framework which they follow in the Houston area. The thing about whole language that's a bit unfair is whole language will differ with respect to how it's defined and taught across different areas. So this is the way it is defined in Houston, and the kinds of teaching activities that go on conform to this particular philosophy. Whole language is a child-centered philosophy of learning and instruction, the implementation of which results in a risk-free, supportive, language-rich environment. This environment is ever-changing, changing to meet the needs of all participants, teachers and students alike. Within this whole language philosophy, students are given a wide variety of opportunities to read, write, learn, and construct meaning, and so in a meaningful context. So the general philosophy then breaks for the 45 minutes into classroom groups, print-rich environments. Teachers are facilitators of learning, fairly non-directive. It is student-centered or child-centered, where the kids read aloud or in shared and guided reading. They respond a good deal to literature read to them. There is a thematic approach to writing, spelling, and phonics instruction. The phonics is clearly from the textual elements, not decontextualized, and so on. Half of the children in this group will also receive 30 minutes per day in a tutorial. So within each of these big groups, half the children not only get the 45 minutes, but then get another 30 minutes in a tutorial that's geared toward the major classroom program. The program that's being used as the tutorial here is a reading recovery format, and I will qualify that to call it an unlicensed reading recovery format, because why do we call it that? Okay, they're not certified reading recovery teachers. And this study is now proceeding again this year with certified reading recovery teachers trained by people in Ohio. So the same kinds of things you might see in reading recovery or in those 30-minute kinds of interactions are listed for you there. Second kind of program is Elfrida Hebert's Chapter 1 program, which emphasizes onset rhyme kinds of things and does look at word patterns sometimes from that old linguistic perspective of an onset, which is your initial consonant or consonant cluster, and then the medial vowel and everything after it. So, for example, instead of k-at, kids would be learning k-at. With me? So forth. That's going to be embedded in context in many cases. its tutorial, it just reflects the kinds of activities that were in the main program, 30 minutes per day, and again, a 1-to-1 ratio. Then there is an open court curriculum used. The only reason open court was chosen for this is, as you can see, it has a combined curriculum which goes after phonemic awareness activities, blends that into phonics after lesson 30, and by generally the 5th stage of the program begins whole language instruction to some degree using shared reading of big books, text anthologies with uncontrolled vocabulary, writing workshops, and so on. So here is what would be the counterpart to the earlier studies combined program. Its tutorial was 30 minutes, again, going after the major kinds of things used in the classroom program. So if everybody's got the design, what you have are 3 contrasts being taken care of. Each contrast is split into 2, the whole classroom program plus kids in a tutorial plus the classroom program. These are the dependent variables that are looked at over at least 3 times over each year, and then over each of the 5 years. And if you, 175. And this year, 125. 140, I'm sorry. So the power is quite extensive. That's why the dependent variables can be broken this way, and also the data analysis is not pre and post. If you do those kinds of things, those will give a pre and post design is going to give you a nice window on relative growth, but the interpretation of growth using pre and post tests is very, very dangerous because of something the statistics will do called regression toward the mean, and it also is very dependent upon the reliability of the measures. We measure at least 3 times per year in every one of these studies on every one of the variables. That's so we can do growth curve analyses, which tell us not only how far kids have moved, if they move, but how quickly they can do it. And that's what I was showing you before, the individual curves. We can look at individual kids as well as groups. It is not a good idea, if you're doing research in intervention, to ever use a pre and post design. We couldn't get that through the National Academy of Sciences whatsoever. Very dangerous kinds of things to use. So anyway, this list of variables is what's going to be measured several times per year. And what you got are, in terms of the ability to understand the sound kinds of things, the top line there moving from about the 12th percentile to about the 48th percentile in phonological awareness is your combined group. There were no differences in the embedded phonics or the 2 whole language groups, which are significantly below. This is the classroom instruction now. And that's the ability to identify sounds within words. The ability to read words and comprehend them moves in the top group from about the 12th percentile up to the 49th percentile. These are Title I children again. Disadvantaged kids moving from the 10th percentile up to the 49th. Again, no differences. Generally, the other groups came from about the 12th percentile up to the 19th percentile on average.
So is the top line over the
Yes, ma'am. In both cases, the top line is the combined group. We're not in the business of supporting particular curricula. We can't do that. We use this particular model. It happens to be that open court thing, but we looked at it because of its components. It's got phonological awareness, phonics, and whole language to it. Now, the surprising thing, which is undergoing replication now, is when you add the tutorials to this, the trends don't change. The classroom instruction took up most of the variance in the change. So we don't know if we had the fidelity in treatment was quite good. They're videotaped, they're monitored, they all appeared to be on cue with what they were doing. In replication, we're trying to figure out why that is. Frankly, to me, it's counterintuitive because we're working with kids, for example, in these lower groups now 1-to-1, and they are not bumping up beyond their classroom instruction. So something is, again, it's probably going to go back to for which children, which is something we always forget in the business, by the way. You know, we're into that one-size-fits-all stuff. So we always forget for which kids does A, B, and C work, or A plus B and C work, rather than generally we kind of hang on to this is the best thing for all these lousy readers. Well, these readers, even if they're all below the 25th percentile, differ quite a bit in some of their characteristics. So it's important for us to figure those kinds of things out. So again, we're continuing to see that common sense seems to prevail if you bring to bear direct instruction and systematic work on these foundational skills and ensure that those are embedded into literature contexts where practice is the key and the initial literature contexts are controlled to jack up the opportunity for practice and the development of fluency, then we're starting to see these kinds of things. But remember now, we have the capability to pull any individual child out of any of these programs and look at their progress and look at all of the things that influence their progress. And I will tell you this, that no one program that we're testing across these multiple sites hits all kids equally well. In fact, a lot of them with licensed reading recovery is leaving behind about 30% of the children. And of course, that's the national trend. Generally, that's basically what you're going to get with that particular program if they were to design it in a way where it was a bit more valid in terms of what they're reporting. The open court is going to leave behind quite a few children. The embedded phonics that does use some of that old linguistic patterning stuff doesn't do as well as we thought, and it's primarily because kids are basing on the aspect of the rhyme rather than going into the internal details of the word. So no one approach that we've seen is equally efficacious, certainly as if we were looking at medications or surgical procedures. For certain children, certain approaches are carrying much more powerful weight than others. And the reasons for that, again, map onto the scientific findings that, in fact, certain conditions appear to need to be in place for children to learn to read accurately, fluently, and in text with a good degree of power so that they can get some meaning out of it and like it. So that's kind of the state of a lot of these studies now. There are 12 new studies ongoing as we speak where the data are coming in, and they are converging on these data. One is in the Journal of Educational Psychology coming out shortly here in 2 months or so that converges on this with an entirely new sample. And so what we're getting, at least with these kids and with other well-defined kids, appears to be pretty stable. I clearly don't think we have learned, obviously, as much as we need to, because not only does each of these approaches leave kids behind, but 5%, 1.8 to 5% of children who have been exposed to wonderful language and literacy activities and family life when they're young do not respond well even to one-to-one intervention in these studies. So we're doing something wrong with them. Or it could be that accommodations are going to help those kids become literate in some ways because we haven't figured out how to get the speed and the automaticity up via any of these procedures or combinations thereof yet. But the good news is that when you're looking at Title I kids, you can get kids generally up to the national average if you have these combined components working fairly well, being monitored well, and so forth. So before I introduce Louisa, I do have one other thing to show you. Let me see. All right, what we're trying to study here is something that's okay. Is something very difficult. We could study all the kids we want, but what's been fascinating to us is we can't remediate their parents. So here are real, this is real. These are actual excuses written by parents that talk about why kids have been absent. So the top one says, "Dear school, please excuse Larry from being absent on January 28, 29, 30, 31st, 32nd, and also the 33rd. Please excuse Diane from being absent yesterday. She was in bed with Gramps." These are real. "My son is under the doctor's care and should not take physical ed, F-I-Z-I-C-A-L, ed. Please execute him." Notice that syntactic, semantic, and graphophonic errors are present. This is a nice semantic one. "Charles was absent yesterday because he was playing football. He was hit in the growing part." This is for the language connoisseurs. "Please excuse Ray Friday from school. He has very loose vowels." I know this is a little blue. I don't want to offend anybody, but this has got a good, "Please excuse Blanche from gym, J-I-M, today. She is administrating." I thought that would be particularly useful for our group today. "Ralph was absent yesterday because he had a sore trout." Last one says, please excuse Johnny for being, it was his father's fault. Now this one I'll get in trouble for, but it cracks me up, so I'll share it with you. It says, please excuse James from being absent yesterday. He had dia, D-I-A-H, crossed out. Dia-ho, D-I-A-H-O-A-H, crossed out. Dia, D-Y-A-H, crossed out. The shits. Turn that up. Those are real. And I know when the evaluations come in that I'm going to get hit on this. I know that, but I take the risk. Somebody's going to say, we don't appreciate the use. Well, it wasn't me that used that language. It was somebody's parent that used the language.